Hello, everyone. Welcome. If you can put in the chat your email for attendance and something you're grateful for today, we could start off our meeting with some gratitude. Okay. I'm grateful that you are all here today and for this Jeopardy style review sessions. So for the format, I'm just going to ask the question, and in the chat, you could put down what you think the answer is, or you could shout it out, and then we could discuss it if you guys want to ask me questions about that. You guys ready? Okay. So proteins. How are proteins created? What is that process for it in our bodies? Yeah, how are amino acids created? So here is how proteins are created. Our DNA the is basically like a blueprint that shows what different kind of proteins need to be created. And then the messenger RNA reads the DNA and tells the ribosomes in the rough RNA, the rough ER, and then the tRNA turns it into a polypeptide chain. And there's a bunch of cool animated videos for it on YouTube. So if you are a visual learner and you want to see that for yourself, you could just type in how are proteins created in our bodies and it will pop up. Does anyone have any questions about this? Name of the process is called translation and transcription. Good question.
Could you could you also think of this as like the central dogma? Like would that kind of fall in like theory with like that process?
Yes, because every end
Okay.
result of whatever is created, they end up turning into polypeptide chains. And when you cut them, they turn into functional proteins when they are in their tetrary structure. I mean, quaternary structure. Why does our bodies need proteins?
like basically for everything was like the very general message. Like they like serve as enzymes or like they like, carry out different processes.
Hmm. Dr. Rose just describes it in one sentence as it does the work of cells. And here is it in way more detail that than you really need to know. But it's kind of cool because when you think of like what the function of lipids and what the function of carbohydrates are, it's like you could summarize it in one word, like lipids store energy, carbohydrates is energy, but like proteins, there's just so much things they can do. Does anyone have questions about this? Oh, another fun thing I remembered is that right here it says we can't store proteins in our body, so it just gets converted into fat. And the fat is stored in adipose cells and in the liver. Okay, next question. What causes proteins to denature and why is denaturing proteins important? Yes, acids is one in heat, enzymes, acid, alkaline solutions, agitation, and denaturing proteins reduces its biological activity. Sometimes you don't want proteins to work. So if you are trying to get nutritional value out of proteins and it's going through you, you don't want it to do its function that you got from the animal you consumed or the plant you consumed. You want it to get broken down into its like monomer, its basic component, and doesn't have its function. Because that would be kind of silly if you eat it and it still maintained all of its function throughout it traveling its your GI tract. What are food protein allergies? Nuts, eggs, soy, dairy, gluten. Yeah, these are examples of food protein allergies, but does anyone know what they are? They are proteins our immune system mistakes for harmful invaders and overreacts. And in when you introduce these two babies, they usually recommend you do it after 6 months because when it's before that, their immune system is not developed enough. And even like when people grow up and stuff, sometimes our the immune system overreacts, even though it's like eating like lactose and stuff. It's or like a dairy allergen is like not, harmful, but our body just thinks it. So how does protein move substances across the plasma membrane?
Is it like something similar to diffusion, but it's like active and
Yep.
yeah, it's like concentration based.
Mm-hmm. Yeah. Proteins tend to be carriers. So they could be pumping sodium or potassium, and you need like a substrate and it like changes it, confrontational change and all that. Sometimes that could happen. Um, and sometimes they are active, they need ATP and they help move things across your gradient. And if it's like regular diffusion, you wouldn't need a carrier because it will just passively move on its own. And if you guys have any questions on any of these, you could type in chat or jump in whenever. Okay, our next section is lipids. What are cis and trans fats? And like what causes it?
Isn't it with like the formation of the bonds and they're like on either the same side or like differing sides?
Yep. Cis is facing each other while trans, the hydrogen's on the opposite side. It's created by hydrogenation, and it's when you straighten out double bonds. And this is very unnatural. Like it's not, you can't really find this in nature. But the quality that you get from this is you turn a very liquid lipid and you give it like more solid, um, like solid in matter. So when you go to the grocery store and stuff, sometimes you find like margarine or some or like you find margarine or something like that that was originally like an oil, but it turns into this like chunky butter like texture that isn't really butter, you know? So that's what cis and trans fat could look like. Trans fat have actually been banned in the US because our bodies cannot break it down. So we just consume it and it goes through, which is kind of interesting and strange. And this whole thing will be uploaded on YouTube later, and I'll send it out. So if you guys are taking notes and I'm going too fast, you're welcome to go back to the video and look at these slides. We've only got 40 minutes together. What are signs of fatty acid deficiency?
Like flaky skin and like dry skin.
Yeah, that's one sign. And diarrhea, hair loss, and it restricts growth in children. But honestly, if you like deplete like any of these nutrients or in like children, it will restrict growth to some degree. So fatty acid deficiency. What are chylomicrons and why are they important? Yes, it's a lipoprotein. Out of all the lipoprotein, I wish I have a picture of this. It looks so crazy because it's just this like conglomerate thing of like triglycerides, dietary lipids, cholesterol, salt-soluble vitamins, and it's just like packed in this like asteroid looking thing that looks really gnarly. And it helps move things, transport things. So when you break down lipids, the fatty acid chains, first, like our body does so much work to break it down to pass through the small intestines through, but as soon as it get through the small intestines, it has to get transported. So it reassembles as a chylomicron. So all that work we did, use up so much energy to break it down just to put it back together, is our body is so inefficient for that. And one of the reasons is because fat is not soluble, water soluble, and in our body we have a lot of water. So it makes sense that we need this, but it's also a bit goofy. Any questions? What are the differences between low density lipoprotein and high density lipoprotein? And here's a hint. One of them is called the good cholesterol in quotes and the bad cholesterol. But why are they called good and bad? So LDL, yes, you're right, Riley. It can, well, it doesn't block it, it collects a bunch of cholesterol. So low density lipoprotein, it carries cholesterol that's made by the liver and from other sources like what we consume to cells. And the crazy part is our liver actually makes enough cholesterol for us and we consume more in excess. And so the high density lipoprotein goes around collecting the excess cholesterol or like the oxidized cholesterol, like it's like already like done. And it tells the liver to stop producing cholesterol because we don't need that much, and we already have some being created. And then it helps get rid of the cholesterol from our body. So one is called bad. The LDL is called bad cholesterol because it increases the risk of cardiovascular disease that we're going to go over later when we talk about heart attacks. And then for high density lipoprotein, it's called the good cholesterol because it helps remove cholesterol from the body. It tells your liver to stop producing it. What are the differences between omega-3 and omega-6?
It's where the carbon it's located, I think,
Yes, you're right.
in the fatty acids.
Mm-hmm. So this is like, I guess, a lot of more information that you need to know. On the molecular level, it is where the carbon is located, and these are essential fatty acids because our body uses it to create other fatty acids that we need. And consume like when you get an injury, sometimes like people recommend doing eating more omega-6 foods because it helps with blood clots, and omega-3 it decreases blood clotting. So there's like a delicate balance of eating both and not just one, because if you consume way too much omega-6 you might get a blood like too much blood clots. And if you consume too little omega-3 you're just going to keep bleeding. Your blood won't clot. So it's recommended to consume both. And the sources of food for omega-3s and 6 are both up there. Okay, this section is about hormones, absorption, and digestion. What is CCK? Does anyone know where it's produced or what it does, what it releases? Yes, it does releases trypsin. It tells the pancreas to release enzymes like trypsin to break down peptides, amino acid, and it tells the gallbladder to release bile to break down fats. And it causes lipase to be secreted. Like we talked about before, lipase breaks down lipids. And it also suppresses appetite, regulate hunger. Oh, I forgot the R. Regulates hunger and stimulates peristalsis, which is like the movement of time through your GI tract through that wave-like motion. How are lipids digested and absorbed?
Um, it starts in the mouth. I think it sends a signal, and there's this like hormone that is released in the stomach. I believe that's how it starts.
Yeah, in the in the stomach, it absorbs primarily small and medium chains, but anything bigger than 12 carbons, it has to be broken down significantly. Like, have you seen those pictures of fatty acids? They're just so enormous and long, and our small intestines is too small for them to fit through. So we have to break them down through bile acids to emulsify the fat to create surface area for the pancreatic lipase to get to the lipids, easier to digest. And then it reorganizes itself as chylomicrons. And then the chylomicrons enter the lacteals to the lymphatic system because they're huge and enter the bloodstream where they travel around our body to be dropped off in cells or adipose tissues. Does anyone have questions about this? How is protein digested and absorbed? So cooking, like even before it enters our GI tract, it's already starting the breakdown of proteins because it's denaturing the proteins like we talked about, heat, acid, and all those do that. And then once it gets to our stomach, it is acid, pepsin, and gastrin starts digesting it, breaking it down. And then the small intestine and CCK and trypsin and protein as amino acids. They move through the microvillus surface and absorptive cells lining small intestines. They're soluble in water, so they don't need to be reassembled and repackaged like lipids do. And it's through active absorption. Then it goes through the portal vein to the liver. Any questions about this process? What are the functions of insulin and glucagon?
Like to regulate glucose.
Mm-hmm. Can you be more specific? Like which one does what to glucose?
I think insulin raises it, right? Or
Oh, yeah, I have a nice picture. So, insulin, I don't know if Dr. Rose talked about this, but it's also called our fed state hormone because when we eat things, our insulin levels increases to break down the glucose either for storage or to be used. And then glucagon, it's called a fasting hormone because when you're not eating anything, it is released to in response to low blood glucose and it breaks down all not all but like your glucose glycogen storages in your liver to be used in your bloodstream. So yeah, Jana, it's raising and lowering blood sugar levels. And they do like a, I think we talked about it in the other midterm review, but it's like they do a fun dance. And it's like if there's more insulin is less glucagon and less glucagon insulin. So it's like they take turns and stuff like that. Any questions about this? Okay. What are the differences between type 1 and type 2 diabetes?
type 1 is genetic, right? Or it's or I guess they both can, but type 1 you're like born with it or you're
Well, type 1 specifically is there's no insulin autoimmune attached. And type 2, there's some insulin. And these are the columns comparing them. And yeah, type 1 is genetic and type 2 you become resistant. And they're very similar to each other. One is more severe than the other, but there's a lot of treatment for it now. So in the past, when they were like experimenting with insulin, they would give people too much and they would die from that, unfortunately. But it's a very it's come a long way, the treatment plan for both. Any questions? Okay, our next column, carbohydrates. What are the differences between glucose and glycogen?
Glucose is a monosaccharide, and then glycogen is how it's stored as a polysaccharide
Hmm. Specifically for animals.
for
Does,
animals.
do you know how plants store their energy storage? Like what form?
Is it amylose?
It's cellulose.
Oh, cellulose. What's amylose?
Amylose is another like what's it called? Like highly like chained carbohydrates. Okay. What is lactose intolerance? Oh, it's called highly branched. That's what amylose is.
Um,
The body can't process the protein for lactase, unable to digest dairy proteins. You're not able to break down lactase. Lactase is actually the enzyme. The sugar that isn't broken down is lactose. And so people who are lactose intolerant, they don't produce enough lactase enzymes. And so all of the lactose that isn't digested moves to the large intestines and all the bacteria in it metabolizes it, which causes a lot of gas, bloating, cramps, and the runs. And this is not the same thing as a dairy allergy because it's not an immune response. Like your body doesn't see it as foreign, it's just we don't produce enough of the enzyme, and some people would just consume lactase to like consume the enzyme to break it down, or consume products that is already breaking down, like it has the enzyme in it. Like Lactate is a company that does that. Why do we need to consume complex carbs instead of just glucose or other monosaccharides? Because wouldn't it be easier just to only eat glucose, get that energy when you need it, get it straight to your bloodstream, like just eat that candy? Like, why do we need more than that? Like, why do we have to eat beans? Why do we have to eat grains? Yeah, fiber, it's important to get. Like, candy does not give you fiber. It's just straight glucose, it feels like sometimes. That's why kids get sugar spikes and rushes. The fiber does slow it down. That's true. It controls the rate of how sugars go into our body, and primarily through having fiber and other phytochemicals go with it. So it's not just that thing being broken down. And compared to eating like beans or short grain rice or even just straight candy or straight like table sugar, Um, if you are needing like a sugar spike, then eating something that is very highly chained, like beans, will actually not be effective because the beans will slowly break down over time and you're just gonna get that energy like at a steady rate. While compared to eating like straight candy, a lot of sugar is released into the bloodstream. And this is why it's recommended to eat fruit. Like if you have food in your like dinner plate, to eat that first, because fruit has not a bunch of highly branched or chained um glucose, carbon bonds, so the energy will be broken down really fast. And sometimes when people consume fruit after they like eat their whole dinner, then you're just gonna get like a random spike later.
Hmm.
What are the differences between sugar alcohols and artificial sweeteners? Yes, calories. Sugar alcohols is about 2.6 calories per gram, while artificial sweeteners has 0 calories. And they both have less calories than just eating sugars, like table sugar. But there's a lot of different options these days. What are the differences between soluble and insoluble fibers? Yep, insoluble fibers cannot be broken down because it's primarily cellulose, like we talked about, energy storage for plants. And our bodies actually doesn't, we don't have the enzyme to break cellulose down. And I know like some animals, they have like 4 stomachs, so they could get as much nutrients from cellulose, like cows. Um, but even though our body can't absorb cellulose, it makes really good volume for poop. It like helps move things and like, through the GI tract. And then insoluble, it is dissolvable. Soluble is dissolvable or absorbs water, and it feeds our gut microbiota in the large intestine. So the more diverse soluble fiber you eat, like if you eat one peach every single day, and that's the only soluble and insoluble fiber you have, your gut microbiota is not going to be very diverse. And the more diverse it is, the less like health problems you're going to have. There's like a new documentary that came out on Netflix recently that talks more about this if you want to know more. It has a really cool felting animation along with it. It's on Netflix. I forget what it's called. I think it's like Trust Your Gut or something like that. Does anyone know? Don't remember. But the example she used in class, the apple, like the outside is the roughage, while the inside is, the soluble fiber. Can you guys in the chat just put down a soluble fiber and an insoluble fiber that you could think of? I feel like having more examples help paint these very abstract words sometimes. Oh yeah, celery. You could see the stringy bits. Like when I was a child, that was the one vegetable I hated because it's like so stringy. It's mostly vegetables in the chat, but fruit can also be soluble and insoluble. Or even like eating leaves, like kale, like the stem of the kale is so thick and like fibrous. I don't know how people can eat that. That doesn't even taste good. It's very bitter. Okay, our last column. What are benefits of a plant-based diet?
Probably less cholesterol or yeah, less centric fats.
Mm-hmm. Less saturated fats, lower risk of heart disease. I remember seeing like a picture where they compared like someone who was vegan and someone who ate like an omnivore diet, and like the plaque around the wall size was different. And I was all like, oh, that makes a lot of sense because there's less saturated fat and so it lowers risk of heart disease. So here are other examples. hypertension, diabetes, cancer, obesity is lowered, and increased longevity, intakes of these vitamins and minerals that we haven't gone over, and phytochemicals. There is one thing that she talked about in class that people who consume more plant-based diets have to be wary of. Do you guys remember what she talked about?
Protein intake.
About complementary proteins. Do you know what complementary proteins are? Do you guys anyone remember?
I remember the example being like rice and beans but is it to like um was basically to try to get the same amount of protein you'd get from eating meat or
Yeah, so proteins that are complete, they have all 9 essential amino acids, and so does soy milk, and oh gosh, there was one more plant, or like dairy products and soy. They are like the only proteins that contain all essential amino acids. And when you eat primarily plant-based, and if you don't consume soy, it's harder to do that. So it's important to complement the proteins. Say like rice has like 5 of the essential ones and beans have the other 4. So you consume both to get all 9. And so just diversifying that could help complement each other, and then you won't miss out on anything, on any of the essential amino acids. So that's what complementary proteins mean. But there's like a lot of lists online, that shows you which complements what and which proteins lack which amino acids, like which plants. That's pretty fun. If you need help with that, there's a bunch of lists online. What are the RDAs for proteins, lipids, and carbohydrates? Does anyone have these memorized? One of them is really silly. Like it makes a lot of sense once we talk about it. Yeah, protein is 0.8 kilograms per body weight. What about for carbohydrates and lipids? For carbohydrates, it's 130 grams a day. Well, lipids, yeah, it is 130. Lipids have no RDAs because people really don't need help consuming lipids. It's like everywhere. So they don't have recommendations. Like if you look at um like the nutrition facts, it won't tend to not have like a percentage too, or it's not even included. I'm not certain, but it makes sense if you think about it. Okay, we have 3 more left. Do you guys want to go overtime, or I could just go over it on Friday? Like, do you guys want me to continue? But if you guys have to dip, like, you guys are welcome to because it is time. If you want to stay to find out what the last 3 fun questions are, you're welcome to too. Just make sure you have your email in the chat so I can take attendance. How many calories do lipids, carbohydrates, and protein offer per gram? And the hint is 2 of them have the same number, so it's kind of easy to remember. Yep, carbs have 4. And proteins have 4. You're right, Riley? And 9 for fat. Is coconut oil long or short chain fatty acids? Nope, it's not long. It's actually medium, which is why it's kind of one of the most insane plant oils. Because when you store it at room temperature, it's actually a solid. Like, has anyone seen this? And then when you melt it down, it turns to a liquid for a very long time until it gets really cold, and then it becomes a solid. And it's because it's super saturated. It absorbs more easily than butter too. because it has more medium chains than butter. And my registered dietitian professor that I took it with last year, she told us that coconut oil is one of the most effective, like, food for a treatment plan for people who are underweight that need to gain weight. Like if they're very malnourished and they really need to gain weight, to be healthier, they would just consume a lot of coconut oil. And it's also better with people with digestive problems. So that's the fun fact that about coconut oil. You see it like all over the media and stuff. And like in class, we talked about how you have to be very careful when you consume this. If you're not underweight and you don't really need to gain weight for like a health, life, and death situation, then it is super saturated. Like if you were vegan and you only use coconut oil and consume it like in large quantities, it could lead to like cardiovascular disease. Like it's something that has a lot of polarization. But fun topic. Okay, and our last question is, how does a heart attack occur? What is cardiovascular disease? Does anyone want to try to describe this, all 4 steps?
Isn't it like plaque buildup in the arteries and then like there's no more blood flow, but like things can't get through and then your like heart stops.
What causes the plaque to build up?
Like eating things that are like or like LDL and like eating more like animal fats and stuff like that causes more plaque.
It's actually a vessel damage. So eating a lot of like saturated fats and stuff does cause plaque to build up, but in order for it to like accumulate and stay there, there needs to be like an injury, a damage to the blood vessel. And I just think about this like a micro tear or like a cut or something. And that is usually caused if you were like a constant smoker or like if you have diabetes or hypertension or high LDL levels, or even infection or like chronic inflammatory response. And buildup of plaque is excessive cholesterol sometimes. And then when there is an injury, all of the white blood cells like accumulate there to try to like fix it. And it engulfs the oxidized. Oh, I spelled that wrong. But you guys know how to spell oxidized, I hope. The oxidized LDLs from the circulation, they all just accumulate and creates the plaque. And when the plaque is created, it's very dangerous because it causes high blood pressure and vasoconstriction. And if there was a blood clot and it lands there, then it causes either a stroke or a heart attack, depending on where it is. So they want to. Oh, also some people like could be perfectly healthy and like don't do any of the factors that lead to a vessel damage, but still get a blood clot and like get a stroke and a heart attack. So it's like your chances increase of getting a heart attack or a blood clot or a stroke if you do all the things that cause vessel damage. But even if you don't, like some people, unfortunately, health people, it does happen, unfortunately. Does anyone have any last thoughts or comments or anything? This review session will be posted on Canvas after Friday because I'm going to be reusing these questions. So if you guys want to come again on Friday and rehear it a second round, you're welcome to, but it's just the same material. Of course. Thank you guys for coming. Have a great rest of your Wednesday night.